right, we're going to go through this benchmark review for our semester 1 benchmark test. So these are things that we were supposed to have learned this semester. Some of them we have learned, other things we haven't had time to get to yet. This first one, what is the name of the following pattern? This is one we learned a few days ago. We read a book about him. It's called Fibonacci Sequence. So if you haven't done that assignment or read the book yet, I highly recommend that you do that. Question number 2, what are the next two numbers in the sequence? Well, if you didn't read the book or do that assignment, you may not realize what's happening here. So let's look at it. We add two numbers together and we get the next number. So like 1 plus 1 equals 2, right? And then 1 plus 2 equals 3. And then 2 plus 3 equals 5. And then 3 plus 5 equals 8. 5 plus 8 is 13. 8 plus 13 is 21. So the next number would be 13 plus 21, which is 34. And the next one after that would be 21 plus 34, which is 55. And you can keep going like that, right? So we add two terms to get the next term. Okay, find the following number of the sequence and describe the sequence. So let's see what's happening. How can we get from 0 to 1? We wouldn't multiply anything because multiplying times 0 is 0. So if we do 0 plus 1, we get 1. What about here? How can we get to 3? 1 plus what? Like add a 2, and then 3 to 6 would be adding a 3. And then 6 to 10 would be adding a 4. So then we add a 5 to get to the 15. So what are we going to have to do to get the next one? Add 6. So 15 plus 6 would bring that up to 21. So I kind of described it by just writing this down, but you could write down a sentence that explains it if you want, like add increasing integers. I don't know. I'm just writing something down that makes sense to me. Okay, find the 15th term of the sequence. So since we haven't learned a lot about these types of sequences yet, the best way to do this one might be just to write them out. So we have term 1, 2, 3, 4. So if we want the 15th term, we got to figure out what the pattern is first. It looks like getting from 2 to 5 and 5 to 8 and 8 to 11, all of those it's adding 3. Doesn't that seem reasonable? Like it's adding 3 each time? So if it's adding 3 each time, we want to add 3. So 11 plus 3 is 14. That gives us our 5th number. We can just keep adding 3 if we want. 17 is our 6th number. 20 is our 7th number. 23 would be our 8th number. 26 would be our 9th number. 29 would be our 10th number. Let's see, 32. 32 would be our 11th number. So then add 3, we get 35 for our 12th number. Add 3 again. So that would be 38 for our 13th number. And then 41 for the 14th number. And then add 3 one last time and we get 44 for our 15th number. So the number that's the 15th number would be 44. Now that could take a long time, especially what if you had to find the 100th number. 15 wasn't too bad. It got a little annoying. What's another way we could do this more quickly? So they gave us 4 numbers, right? We wanted to go to the 15th number. So how many numbers is that between 4 and 15? So 4 to 15 is 11 numbers. And each number goes up by 3. So if you add 3 11 times to get to the 15th number, can't you just go 3 times 11? so you would be adding 33 to the number you already have. So instead of having to go through and count each one, you could actually just take the 11 and add 33 to it to get the 44, because it's just the same amount each time. So we can just simplify that. Repeated addition is just like multiplication, right? So that's just a hint on how to have made that one easier. This one is called an arithmetic sequence. It didn't ask me to answer that, but just to review, that's when we add the same number each time. We call that an arithmetic sequence. Okay, next, what type of sequence comes from repeated addition? We just talked about that. It's arithmetic. So let's look at this example. In this example, it's multiplying by 3, isn't it? Wait, is it? No, it's adding. Sorry. Repeated addition. What number is adding?
3.
Yeah, it's adding 3. Just in our in our last problem, it's just starting a different place. Okay, what type of sequence comes from repeated multiplication? We call that a geometric sequence. If you want plenty of time to do the benchmark, I want to jump into School City because you're bored of listening to this. You can jump in and just get your test done at any point, but I'm just going to go through these problems. So geometric, what's happening in this sequence to go from 1 to 3, 3 to 9, 9 to 27, 27 to 81?
Multiply by 3.
Yeah, it's multiply 3, right? Good. Okay, we already talked about these briefly. When the dots representing an arithmetic sequence are graphed, they are a straight line. So an arithmetic sequence has our straight line dots. We're just adding the same number, it just goes up at a constant rate. But our geometric sequence is multiplying, so it goes up much faster, so it gives it more of a curved graph. Number 9, this pattern we learned about a few days ago is called Pascal's triangle. And to create Pascal's triangle, we just add the numbers in the row above to get the next row below. So Pascal's triangle, so like we start with 1s, and then 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. We just always start and end with 1. So let's figure out the next row. So we start with a 1, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and we end with 1. So we can keep going with this pattern as far as we would